Following question reads that a small crystal of purple KMnO4 and orange K2Cr2O7, the MR is also provided, were placed at the center of separate petri dishes filled with agar jelly. They were left to stand under the same physical conditions. So you have these petri dishes with K2Cr2O7 and KMnO4. The colors are also given, and after some time, the color of each substance had spread out as shown. So you can see over here that KMnO4 was placed over here, and now it has spread in the petri dish. In that agar jelly that it was placed in, it has spread and covered a larger region. Whereas K2Cr2O7 was placed over here, it has also spread, but it has covered a smaller region compared to KMnO4. Now, moving to the next part, the question then states that the lengths of the arrows indicate the relative distance traveled by particles of each substance. Which statement is correct? So, the first statement is that diffusion is faster in dish 1 because the mass of the particle is greater. Now, let's go back and have a look. This is a question about diffusion. Diffusion is when particles start moving in random directions due to random movements, liquid and gases. They start moving randomly and they spread. They spread from a region of higher concentration to a region of lower concentration. Now, the rule for diffusion is that particles that have a smaller mass, for example, over here, if you look at this, if you look at these two molecules, you would notice that KMnO4 has a smaller mass. Smaller mass, lighter particles, they travel faster. So this dish with KMnO4 is diffusing faster. Its particles are moving randomly, haphazardly in different directions at a faster rate because it has a smaller MR. So going back to our statements, the correct statement, diffusion is faster in dish 1, that's correct. Because the mass of the particle is greater. No, because the mass of the particle is lesser, it's lighter. So the first statement is incorrect. Diffusion is faster in dish 2, that's automatically incorrect because KMnO4 is traveling a larger distance in the same amount of time, so it's faster in dish 1. Diffusion is slower in dish 1, that's also incorrect. Diffusion is slower in dish 2 because the mass of the particle is greater. This statement is going to be the correct statement because the particles are traveling a smaller distance because they are heavier. The mass of the particles is greater. In the following question, the question reads that impurities change the melting and boiling points of substances. Pure substances, remember, have a very fixed melting and boiling point. Impure substances, their melting and boiling points change and they melt and boil over a range of temperatures. Now, sodium chloride is added to a sample of pure water. So that basically makes it NaCl, aqueous. Now, you don't have pure water, it is a salt solution now. How does the addition of sodium chloride affect the melting point and boiling point of water? Now, remember this, that the melting point, when you add salt to water, the melting point is going to decrease and the boiling point is going to increase. So the water is going to melt at a temperature lower than 0 degrees centigrade. This is the reason why salt is used, especially in countries where the temperature is below freezing point, to melt water, to remove ice from windscreen of car windscreen. Salt is used because it lowers the melting point. It makes it easier for the ice to melt. And similarly, the boiling point is going to increase. It's going to become greater than 100 degrees centigrade. Pure water is 100 degrees centigrade. Now the boiling point is going to be greater than 100. So the correct option is going to be option C. The following question reads that diagram shows a chromatogram of 4 substances. Which substance has an RF value of approximately 0.32? So let's have a look at the diagram. And we need to know the RF value of the substance is 0.32, that's given. The first thing we need to know is what is meant by the term RF value. RF value is the distance traveled by the dye divided by the distance traveled by the solvent. Now, the distance traveled by the solvent is everything would be measured from the starting line or baseline. So this over here would be the distance traveled by the solvent. It travels from the starting line, it travels all the way up to the solvent front. So this is the solvent moving, and as the solvent dissolves the dye would travel with it. So these dye particles are also traveling with it. So the distance traveled by the solvent is going to be 19 centimeters. So let's so this is given as 19 centimeter. and I have different dyes. Now, if you look at dye 1, this first one, let's say it's option A, the distance traveled by the dye is approximately 6 centimeters, which is given over here. So it's 6 centimeters, so the distance traveled by the dye is going to be 6 centimeters. So my RF value for option A, remember I'm calculating RF value for option A, it's going to be 6 divided by 19. And if you do this calculation on your calculator, this would approximately be equal to 0.32. So option A is your correct option. Because the distance traveled by the dye is 6 centimeters and the distance traveled by the solvent is 19 centimeters. Dividing 6 by 19 gives you 0.32. So option A is going to be your correct option. We were supposed to identify the dye that had an RF value of 0.32. The following question reads that which element does not form a stable ion with the same electronic structure as argon? Now, starting with the first one, we know that aluminium's electronic configuration has 13 electrons, so it's 2, 8, and 3. Now, if it's 2, 8, and 3, the aluminum ion that is formed is usually, it's always plus 3. It's in group 3, it's going to be plus 3. So it loses its 3 outermost outer shell electrons. Now, if it loses 3 outer shell electrons, you're only left with 2 electrons and 8 electrons. That's a total of 10 electrons. Now, the question was that it is forming a stable ion. The question was which element does not form a stable ion with the same electronic structure as argon. Now remember, we have to compare it with argon. Argon had 18 electrons, so argon's electronic configuration is going to be 18 would be 2, 8, and then another 8 electrons in the third shell. So as you can see, aluminum ions have 2 electrons in the first shell, 8 in the second shell, and 0 electrons in the third shell. Argon's electronic structure has 2 in the first, 8 in the second, and 8 in the third. So aluminium is forming a stable ion, but it is not forming a stable ion that has the same electronic structure as argon. While if you look at the rest of the atoms, chlorine is 17 electrons, 287. So that chlorine is in group 7. It usually forms a -1 ion. If it forms a -1 ion, instead of 7 electrons, they're going to be 8 electrons in its outermost shell, which is going to be exactly the same as argon. Similarly, phosphorus has 15 electrons. Its electronic structure is 2, 8, and 5. But phosphorus forms a -3 ion. It's in group 5. So instead of having 5 electrons, it's going to have 8 electrons, 3 extra electrons in its outer shell. So its electronic structure is going to be similar to argon as well. And the same would be true for potassium. Potassium has 19 electrons. So its electronic structure is going to be 2, 8, 8, and then 1. But potassium forms, it's in group 1, it forms a +1 ion, it loses its 1 electron, so it's also left with 2, 8, and 8 electrons in its third shell, which is going to be the same as argon. So option A is going to be the correct answer because its stable ion is not going to be exactly like argon. The following question reads that graphite and diamond are both forms of the element carbon. Which row shows the number of other carbon atoms that each carbon atom is covalently bonded to in graphite and in diamond? So I'm going to draw the two structures of graphite and diamond. So this over here is the structure of graphite. And as you can see, in graphite, these black dots are carbon atoms. Each carbon atom is bonded to 3 other carbon atoms. This carbon atom is bonded to 3 other carbon atoms. Carbon has 4 outer shell electrons. So in graphite, what happens is that one electron is delocalized. It's used in electricity conduction. It's delocalized. So from the outermost shell of carbon, only 3 electrons would be bonding. 3 bonds would be formed. The 4th electron is going to be delocalized, and it's going to form a hexagonal layered structure. And they would be sheets of graphite, and these sheets would be attracted to each other by very weak intermolecular forces, which are also called van der Waals forces. So in graphite, carbon would be bonded to 3 other carbon atoms. Now let's look at the structure of diamond now. Now this is the structure of diamond, and as you can see, each carbon atom is bonded to 4 different carbon atoms. Each carbon atom is bonded to 4 different carbon atoms. It's a giant covalent structure. So all carbon atoms are arranged in a tetrahedral arrangement, and all the angles are 109.5, but each carbon atom is bonded to 4 different carbon atoms. So your correct answer for this question, it's going to be option B, because in graphite, as I showed you earlier, each carbon atom was bonded to 3 carbon atoms, and the fourth electron in carbon was delocalized, conducting electricity. Whereas in carbon, it's a three-dimensional structure where each carbon atom is bonded to 4 different carbon atoms. So diamond would be bonded. Option B is going to be your correct option for this question. The question states that which statement describes metallic bonding. So the first thing is I'm going to give you a brief description of what metallic bonding is. Now this is what metallic bonds are going to look like, or the structure of a giant metallic lattice is going to look like, where metals, remember, like to lose electrons and they like to form positive ions. So you will have lots of positive ions. All the metal atoms would be losing electrons, and those electrons would be just roaming around. They would be delocalized electrons roaming around in the lattice, and there would be free moving electrons. Now, the reason why all of them are sticking together or bonded to each other is that the positive ions and the delocalized electrons, they are oppositely charged, and if they are oppositely charged, they would be attracting each other. So there's a delocalized electron, it would be attracting the positive ions around it. This delocalized electron would be attracting the positive ions around it. So all the delocalized electrons, which are negatively charged, and the positive metal ions, they would all be glued together. They would all be attracting each other. So coming back to the question, which statement describes metallic bonding? The answer is going to be that there's an attraction between the lattice of negative ions, which is incorrect because metals are going to have positive ions. Second statement looks correct. Option B, the attraction between lattice of positive ions and delocalized electrons. So this statement looks perfectly correct, and this would be your correct answer for this question. The following question reads that which equations are balanced? So you're given 4 equations, and we need to figure out which of these equations are balanced. Now, a balanced equation would have the same number of atoms in the reactant side and in the product side. So starting with the first equation, let's look at Fe. There are 2 iron atoms in Fe2O3, and there are 2 irons in the product side as well. If you count the oxygens, there are 3 oxygens over here. 3 oxygens, because there are 3 carbon monoxide molecules, 3 oxygens, so total 6 oxygens in the left hand side. And if you look over here, 3 CO2 molecules, that's also 6 oxygens. We can also count carbons. There are 3 carbon dioxide molecules, so that's 3 carbons. 3 carbon monoxide molecules, so that's 3 carbon as well. So the first equation looks perfectly right. It's a balanced equation. Moving to the next equation. If you look at the next equation, you would, zinc looks balanced, that's 1, and 1. Carbon is also balanced, the 1 carbon over here, 1 carbon over here. If you look at hydrogen, there are 2 hydrogens over here, and over here there are 2 water molecules. That means there are 4 hydrogens. So this equation, the hydrogen is not balanced. Let's now look at the third equation, which is magnesium nitrate plus NaOH. So this equation is given. Let's start counting the atoms. Mg, 1 over here, 1 on the right side, that's balanced. There's 1 Na over here, and there are 2 sodiums on the other side, 2 sodium nitrate molecules, formula units, so that's 2 sodiums on the right hand side. So this equation is not balanced, because if you look at sodium, it's not balanced. Sodium over here is not balanced. Let's move to the fourth equation, which is calcium carbonate plus sulfuric acid. So this equation is given. Calcium 1 and 1, that's balanced. SO4 1 over here, 1 over here, that's balanced. Carbon 1 over here and 1 on the other side, that's also balanced. You can count the oxygens. 3 oxygens plus 4, that's 7. 4 plus 1, that's 5. 5 plus 2 over here, that's 7 as well. So this fourth equation also looks perfectly balanced. So your correct answer is going to be B. 1 and 4 are balanced chemical equations. In the following question, the question reads that calcium carbide, which is CaC2, it reacts with water to form ethine, which is C2H2, and calcium hydroxide. And the equation for the reaction is also shown. So there is CaC2 plus H2O, and it's forming C2H2 and calcium hydroxide. The question now is, which volume of ethine is produced when 6 grams of water react completely with calcium carbide? So we are given the mass of water, which is 6 grams. The first thing I need to do is I need to find out how many moles of water do I have. So moles of H2O need to be calculated. Moles is mass divided by the MR of the molecule, which in this case the mass is given as 6 grams, and the MR is given, MR of H2O is, there are two hydrogens and one oxygen, so 16 plus 1 plus 1, that's 18. So it's 6 divided by 18, which would come out to be equal to 1 by 3 moles. So I have 1 by 3 moles of H2O over here. Now the question wants us to calculate the volume of ethyne. The first thing I'm going to do is I'm going to find the moles of ethyne. The moles of ethyne and the moles of water have a ratio, it's 2:1. According to the equation, two water molecules produce one molecule of ethyne, which means it's 2:1. So if I have 1 by 3 moles of water, the amount of ethyne that's going to be produced according to this, it's going to be 1 by 6 moles. It's going to be half of that because it's 2:1. So two molecules produce one molecule of ethyne. So if I have 1 by 3 moles according to this ratio, it's going to be 1 by 6 moles of ethyne. Now I've found the moles of ethyne. The next part is I need to find the volume of ethyne. And the volume of ethyne can be found from the formula. We know that 1 mole of gas occupies 24 decimeter cube. So 1 mole of gas occupies 24 decimeter cube. So the volume formula is that its volume of gas, it's going to be moles multiplied by 24 decimeter cube at RTP. So 1 mole of gas occupies 24 decimeter cube. So if you have 1 by 6 moles of gas, the volume that's going to be occupied is going to be 1 by 6 divided into 24. And this would come out to be, 6 would get cancelled out, 6 4s are 24. So it's going to be 4 decimeter cube. So that is going to be your answer. It's going to be option A would be your correct option for this question. The following question states which statement about electrolysis is correct. Now the first one is that electrons move through the electrolyte from the cathode to the anode. Let's first discuss what is electrolysis. Here I've drawn the diagram for electrolysis, and you can see that there's a battery connected to two terminals. One is the cathode, which is the negative terminal. So electrons are basically moving from the battery. So they're moving from the battery to the cathode. And the other one is the anode, where the electrons are basically traveling back to the battery. So this is the movement of electrons, and in the solution you're going to have ions. You're going to have negative ions and you're going to have positive ions. The negative ions are going to get attracted to this positive anode, where they are going to lose electrons. So they are going to lose electrons, and that would be called oxidation. Whereas the positive ions in the solution, they're going to get attracted to the negative cathode because it's negatively charged, opposite charges. They're going to attract each other. And when they go over there, the battery is going to provide them electrons. So they are the ones that are going to gain electrons. So the first statement, electrons move through the electrolyte from the cathode to the anode, is incorrect because in the solution, it's the ions that are traveling, not the electrons. The electrons are only traveling in the wire. There are no electrons in the electrolyte itself. The second statement, option B, electrons move towards the cathode in the external circuit, is definitely correct because electrons are traveling to the cathode. So that statement looks correct, and hopefully option B is going to be the correct answer for this question. But let's also look at the other options. Option C is negative ions move towards the anode in the external circuit. As you can see, the negative ions are going to get attracted to the towards the anode, but not in the external circuit. Negative ions move towards the anode inside the solution, not this external circuit. So that statement is incorrect. And option D is positive ions move through the electrolyte towards the anode. That is also incorrect because positive ions are traveling towards the cathode. The cathode is negative and they're going to be attracted to the cathode. So this statement is also incorrect. The following MCQ reads that the reactivity series for a number of different metals is shown. So you're given the reactivity series: magnesium, zinc, iron, copper, silver, and platinum. These are the most reactive ones. These are the least reactive ones. And the diagram shows different metal strips dipped into an electrolyte. So different metal strips are dipped into an electrolyte, and the question then asks is asking us which pair of metals produces the highest voltage. Now this is a diagram of a galvanic cell or electrochemical cell. We have different metal strips. Remember, the highest voltage is produced when the difference in reactivity of the two metal strips is very high. For example, I have one strip made of magnesium, one strip made of platinum. So if I have a strip of Mg, and on the other side I have a strip of platinum, the voltage produced would be the highest. And the reason is that the more reactive metal, it likes to lose electrons. In this case, Mg and platinum, Mg is the more reactive one, so Mg likes to lose electrons. It has a very high tendency to lose electrons, so it's going to be producing a lot of electrons, and it would be losing electrons very easily. So there would be a lot of Mg+2 ions being formed in the solution, because Mg would lose electrons to form magnesium ions. A lot of magnesium ions would be produced, and there would be an accumulation of electrons. And these electrons would then start traveling in the other direction where they are lesser in number. So these electrons would start moving from the more reactive side where they're being produced. So these electrons are being produced. They start traveling to the least reactive side. So they would all start traveling to the other side where they would be gained by some ion in the electrolyte. So this is how a photovoltaic cell works. More reactive loses electrons. Those electrons travel to the other side, and the difference in reactivity, if it's large, the voltage produced is going to be very large as well. So in our options, we have which pair of metals produces the highest voltage. You have copper and magnesium. So if you look at the reactivity series that they have given us, copper and magnesium, that's the difference in reactivity. It is large, so it would be a higher voltage produced. But let's compare it with the other ones. You have magnesium and platinum. That is going to produce the most voltage because magnesium is over here, just like our example, is the most reactive one, and platinum is the least reactive one. So that is going to produce the highest voltage. The difference in reactivity, Mg would lose a lot of electrons. Those electrons would travel to the other side, and the voltage produced would be very large. So Mg and platinum is going to be your answer, because the difference in reactivity is highest in this option. So option B is going to be your correct option. The following MCQ reads that which statement about fuels is correct? Remember, fuels are used for producing energy. Now, the statements are that heat energy can only be produced by burning fuels, which is probably incorrect, because there are a lot of ways where heat energy could be produced. For example, you have electric heaters, so you can produce heat energy by electricity. You can convert that electricity into heat. You have the formula for power power is current into voltage. So you have that formula as well. So let's look at the second one. The first statement is obviously incorrect. It can only be produced by burning fuels is not correct. Hydrogen is used as a fuel, although it is difficult to store it. Yes, hydrogen is used as a fuel because hydrogen undergoes combustion. H2 and O2, they react to produce H2O. And that's an exothermic reaction. It's a very exothermic reaction. It is difficult to store it, because it's always difficult to store gases, because gases take up a lot of volume. Gas particles are very far apart from each other, so that you need to compress them. So gases need to be compressed for storage. So it is difficult to store. So this option looks pretty good. But let's compare it with the other options, the two left. The third option is methane is a good fuel because it produces only water when burned, which is incorrect. I have written the equation for the combustion of methane. Reacts with oxygen, produces carbon dioxide and water. So water is not the only product. There's carbon dioxide that is also produced. So this statement is also incorrect. Let's move to the last one. Uranium is burned in air to produce energy. Now, uranium is not burned. It's a nuclear fuel. It produces radiation, and fission is the reaction where the isotope or the nucleus of uranium decays and produces energy. So it's not a chemical reaction, it's a nuclear reaction. So air has nothing to do with it. So uranium produces energy in the form of radiations. So that is also correct. It's not reacting with air. So the most likely correct answer is definitely going to be B. Option B is going to be your correct answer. Hydrogen is used as a fuel, although it is difficult to store it because it is a gas. The following MCQ reads that which statement about exothermic and endothermic reactions are correct? So exothermic and endothermic. In exothermic reaction, energy is released, whereas in endothermic reaction, energy is gained. So which statement is correct? During an exothermic reaction, heat is given out, which is correct. So one is correct. Second one, the temperature of an endothermic reaction goes up because heat is taken in, which is incorrect. when the reaction absorbs energy, the temperature is going to drop. So temperature is not going to go up. Endothermic reactions, temperature drops. And remember, when you're measuring temperature, you're measuring the temperature of the environment. So if a reaction is taking up all the energy, then the temperature of the environment is going to drop. So the temperature goes down. So second statement is incorrect. Let's move to the third one, which is burning methane in the air is an exothermic reaction. Now, this is combustion. This is your normal natural gas that is used for cooking mostly. So when you burn it, an exothermic reaction, heat is released, exothermic reaction takes place. So the third statement is also correct. So your correct option is going to be options 1 and 3 for this MCQ. The following question reads that the equation for the reaction between hydrogen and chlorine is shown. So there's H2 and Cl2 and they reacting to produce 2 molecules of HCl. And he's also told us that the reaction is exothermic and the bond energies are shown in the table. So you're given the values for different bonds. Chlorine is 240, H and Cl bond, that's 430, H and H is 436. And you're being asked what is the energy change for this reaction. So you need to find the net energy change for this reaction. So you need to first figure out how many bonds are broken and how many bonds are formed. The first thing is figure out bonds broken. So the reactant bonds would be broken. There's H2 molecule, so one HH bond would be broken. Remember, count the bonds, not the atoms. So H2 molecule, that's going to have one HH bond. Cl2 bond would be broken, so Cl-Cl bond would be broken, so one Cl-Cl bond would be broken. And then look at your products and see how many bonds are formed. New bonds are formed. So H and Cl, that's one bond, but since there are two molecules, so two HCl bonds would be formed. Now, bond breaking is an endothermic process, so this would be plus. Bond forming is an exothermic process. So during bond formation, these values would be exothermic. So when you're making the bond, it's an exothermic reaction. So the net enthalpy change for the overall energy change would be the sum of the amount of energy that's consumed during bond breaking and the amount of energy that is released during bond formation. So this is the expression that you're going to get. One HH bond broken, that's 430. So that's so HH is 436. So that's 436 into 1. And it would be plus. Bond broken would be positive. One Cl-Cl bond broken, that would be 240. But that 240 into 1, because there's only one Cl-Cl bond broken. Again, it's going to be plus. And then you have your bonds formed. Two HCl bonds would be formed. So that's H and Cl. That's 430. But it's going to be negative because bond formation is going to be exothermic. So two bonds are being formed, so the 430 into 2. And I'm going to now calculate this value, which is going to come out to be equal to minus 184 kilojoules per mole is the answer that I'm getting on my calculator. So the correct answer, let's go down and see the option. It's going to be, you have minus 184 over there. So option B is going to be your correct answer for this particular question. The following question reads that a gas is produced when calcium carbonate is heated. What type of change is this? So the first thing is, you have calcium carbonate, and remember, carbonates, when they decompose, when they are heated, they decompose, they break down, and they always produce an oxide, which is going to be calcium oxide and carbon dioxide gas. So all carbonates, when they decompose, they're going to do the same. Carbonate produces a metal oxide and a carbon dioxide gas molecule. Now the change is, what type of change is this? Now, it's not an exothermic reaction because energy is required. It's an endothermic reaction. So, exothermic is incorrect. It's not a physical change because it's a chemical change. Compounds are changing into different compounds. So, it's a chemical change. The first option looks perfectly correct, and it is not separation. Separation, it is chemical separation. I mean, it's not a physical separation. You can't call it a separation because bonds are being broken and new bonds are being formed. So it's not, you can't call this separation, it's a decomposition reaction. Separation is used for a physical process. For example, if you separate sand and water, that is separation. So without any chemical reaction, so it's purely a chemical reaction where bonds are being broken and new bonds are being formed. So option A is going to be the correct option for this MCQ. The following question reads that a student was investigating the rate of reaction, the reaction between marble chips and dilute hydrochloric acid. So I've written down the reaction. Remember, marble chips, limestone, etc., they're all calcium carbonate or they contain calcium carbonate. So when you're heating marble chips with hydrochloric acid, which is HCl, so a carbonate reacts with an acid and produces salt, water, and carbon dioxide. So this is the reaction that's happening, and the gas that is being produced is going to be carbon dioxide gas, which would be collected. So CO2 gas is the only gas that is being produced, so which is going to be collected in this syringe. So let's move to the question now. The question now is, which changes slow down the rate of reaction? Now it's a question on the rate of reaction. Remember rate. The first thing about rate. The first part is that what would be the temperature of the acid if you want to slow down the rate? The temperature should decrease, because if you decrease temperature, the particles will have lesser kinetic energy, so they're not going to collide very frequently, and the collisions are not going to be very successful, because they won't be having a lot of velocity, a lot of kinetic energy. So that would slow down the reaction. What about the concentration of acid? The concentration of acid should also decrease, because if you decrease concentration, you're going to have fewer particles. If you have fewer particles, they're not going to bump into each other, and there would be fewer or less frequent collisions. And last one is surface area of marble chips. You want bigger marble chips, you want them to increase in size, because if you have bigger lumps, the amount of collisions that can happen would be fewer, because the inside particles would not be able to react with it. So bigger lumps, bigger chunks of marble chips, it's going to slow down the reaction. So the correct option, where all the options are correct, is going to be this option B. Temperature should decrease, concentration should decrease, and the surface area should increase. So all these three are correct in B. The rate of the reaction would slow down. It's going to slow down. The following question reads that the reaction which is used to manufacture ammonia from nitrogen and hydrogen is a reversible reaction. An equilibrium can be established between ammonia, nitrogen, and hydrogen. And which statement describes this equilibrium? Remember, we're talking about the Haber process, which is this reaction over here. All of them are gases, and it's an exothermic reaction in the forward direction. Now the options read that both the forward reaction and the backward reaction have the same rate. Now, since they are at equilibrium, this statement is perfectly correct. This is the definition of equilibrium, that both the forward reaction and the backward reaction have the same rate, the rate at which ammonia would be produced and the rate at which it's going to get consumed back again and form reactants again. That rate at equilibrium would be exactly the same. So equilibrium has been established. So the both forward reaction and the backward reaction have the same rate. So option A is perfectly right. But let's look at the other options. The other option is the rate of the backward reaction is greater than the rate of the forward reaction, which is incorrect, because since it is at equilibrium, the two rates, forward and backward rates, they must be equal. Let's look at option C. The rate of the forward reaction is greater than the rate of the backward reaction. Again, incorrect. And the forward and backward reactions have both stopped, which is also incorrect. So the reaction is happening, forward reaction is also happening, backward is also happening, but the speed at which the forward and the backward are happening are exactly the same, which is why the reaction is at equilibrium, which is why the quantity of ammonia doesn't change, because the amount of ammonia that is being produced and the amount of ammonia that is consumed back, it's the same. So the quantity of ammonia stops changing at equilibrium. So A is the definition of what equilibrium stands for. The following question reads that an example of a redox reaction is given, and which statement about the reaction is correct? So the first thing to remember is that oxidation is a loss of electrons, or increase in oxidation state, where the positive charge increases. Reduction, vice versa, is the gain of electrons, or decrease in oxidation state, where the charge decreases or becomes more negative because you're gaining electrons. So look at this reaction. Zinc goes from zinc to zinc 2 plus, which means that its positive charge is increasing. That means it lost electrons, it's undergoing oxidation. Copper 2 plus is gaining electrons to form copper. Its oxidation state, it was plus 2 and now it became 0. So it's gaining electrons, so that part is going to be reduction. So zinc is getting oxidized, copper 2 plus is getting reduced. Now the species that is getting oxidized is the reducing agent, because it is causing the other substance to get reduced. So it's the opposite. So if zinc is getting oxidized, it's losing electrons, it's making copper 2 plus reduce, it's making copper 2 plus gain electrons, vice versa. So copper 2 plus is getting reduced. So the substance that is getting oxidized would be called the reducing agent, whereas copper 2 plus, which is getting reduced, would be called the oxidizing agent. Now, which statement about the reaction is correct? Now, zinc is the oxidizing agent and it oxidizes copper 2 plus. Zinc is not the oxidizing agent and copper 2 plus is not getting oxidized, it's getting reduced. So it's the reducing agent. Zinc is the oxidizing agent, wrong again. The third statement looks incorrect as well, because zinc is the reducing agent. That's correct because it's making copper 2 plus reduce. It's not oxidizing it. So the third statement is also incorrect. The fourth looks perfectly correct, option D. Zinc is the reducing agent as it reduces copper 2 plus. Copper 2 plus is getting reduced, and who's reducing it? It's zinc. So zinc would be the reducing agent. So this statement, option D, is the correct answer for this question. The following question reads that what type of oxide is aluminum oxide? Now, aluminum oxide is an amphoteric oxide. It's one of the few oxides that are amphoteric. The other oxides, so Al2O3 is one amphoteric oxide. You have zinc oxide and lead oxide. So these are some of the amphoteric oxides. What does the term amphoteric? What is the meaning of the term amphoteric? Amphoteric means that they're capable of reacting with both acids and bases. So they can react with both. So that is the meaning of the term amphoteric, and with both they're going to produce salt and water. So I've shown you the equations for the reaction of Al2O3 with an acid, also with a base, and you must remember these equations because aluminum extraction is in the course, in the syllabus for O levels, and these equations come in those processes. So Al2O3 reacts with HCl, ends up producing salt, which is AlCl3, and a water molecule. Al2O3, on the other hand, can also react with bases or alkalis like NaOH, and they would end up producing salts and a water molecule. This salt, the name of this salt would be sodium aluminate. So what type of oxide is aluminum oxide? That is going to be amphoteric. B would be your answer. The following MCQ reads that which statement about a weak acid, such as ethanoic acid, are correct? Now remember, it's a weak acid. So here I've drawn ethanoic acid. It has this carboxylic acid functional group, and what do acids do? They lose H plus one ions, or they produce H plus one ions. Ethanoic acid does the same, but it's the carboxylic acid group H plus one that it loses. So the H at the end is lost. It produces that H plus one. But since it's a weak acid, the definition of a weak acid is that it partially ionizes, which means that if you have 1,000 molecules of ethanoic acid, only a few of those molecules are going to break down and they're going to produce H plus one ions. So weak acids, they are not going to produce a lot of H plus one ions. So, but ethanoic acids are acids. So which statement about a weak acid like ethanoic acid are correct? It's going to react with a carbonate. All acids react with carbonates to produce salt, water, and carbon dioxide. So it's going to do that, but the reaction would be a lot slower because it's a weak acid. It's not going to easily react. It's not going to lose its H plus one ions very, very easily. So it's going to be a slow reaction. The second statement, it does not neutralize aqueous sodium hydroxide. Sodium hydroxides, all metal hydroxides, they are bases. So bases react with acids. So it is going to neutralize it. So this statement not is incorrect. It does neutralize NaOH. So the second statement, the first statement is correct. The second statement is actually incorrect. Let's move to the third statement. It turns red litmus paper blue. Since it's an acid, acids turn litmus paper not blue. They change it to red. Blue litmus paper changes to red in acidic conditions. And finally, the fourth statement, it is only partially ionized in aqueous solution. This is what I'm talking about. That if you have ethanoic acid, only very few molecules are going to break down and they're going to produce these ions. So this statement also looks perfectly correct. So the middle ones are incorrect. The first and the fourth are correct. So your correct option for this MCQ would be, it's going to be option B. 1 and 4 would be correct. The following question reads that silver chloride is a white solid which is insoluble in water. Silver chloride is AgCl. It's Ag plus 1 and Cl minus 1 ions, and they are this ionic compound is insoluble. Which statement describes how a sample of pure silver chloride can be made? Now I'm going to talk about the preparation of AgCl in detail. AgCl is insoluble, and there's only one way where insoluble salts could be produced, and that method is called ionic precipitation. Now ionic precipitation is since you're trying to make this AgCl, what you're going to do is you're going to find two soluble compounds and you're going to mix them. So first thing is you need to find two soluble compounds, and one should contain Ag plus 1 ions and the other one should contain Cl minus 1 ions, and you're going to mix them. So one soluble silver compound that could be that you could have is, there could be multiple options that are soluble compounds that contain silver ions. So AgNO3 is one example. All nitrate compounds are soluble. So if I take AgNO3, I know that this is a soluble compound and it would be present in aqueous state. Similarly, I need a compound that contains Cl minus 1 ion, and that should also be soluble. So one soluble Cl compound that comes to mind is NaCl. That's very common, and that is soluble. Group 1 salts are all soluble, but there could be lots of group 1 compounds that can have Cl ions. There could be KCl, or you can have acids as well. They contain Cl ions as well, so you can have HCl. So there could be a number of compounds that contain Cl ions and that are soluble. So you're going to pick one soluble compound that contains silver ions and one soluble compound containing Cl ions, and you're going to mix the two compounds together. So if I mix these two soluble compounds together, soluble compounds, remember, dissociate when they are mixed in water. So if you mix silver nitrate in solution, the silver ions and the nitrate ions, they're going to dissociate, and you would have all these silver ions and all these nitrate ions just roaming around in the solution. They would be mixed in water. Similarly, let's pick NaCl. If I take NaCl and if I mix it, it's going to dissociate as well, like the silver nitrate, and sodium ions and Cl ions would be roaming in the solution. So you're going to have lots of sodium ions, lots of Cl ions, and sodium ions randomly just roaming around mixed in the solution. So you have all these ions mixed together. So that's your solution now, and these ions are going to randomly combine with each other. So they would start bumping into each other and they would start combining with each other. Remember, a compound is formed when a positive ion combines with a negative ion. So they're going to randomly combine with each other. But what's going to happen is that if silver ions and let's say this Cl ion, if these two ions, they get together, and over here there's another silver ion and a Cl ion, if they get together, AgCl, remember, we've already talked about AgCl is insoluble. That was the first thing that we mentioned, and that was that AgCl is insoluble. So what's going to happen is you're going to start seeing precipitates of AgCl forming at the bottom of the solution. This AgCl solid would be formed, AgCl solid would also be formed over here, and these ions, they would no longer be present in the solution. They would instead form a precipitate because they are insoluble, and you would start seeing their precipitates settle at the bottom. Here, as you can see, all the AgCl ions, they've now formed this AgCl solid, and they have settled at the bottom, and they would form a solid. And your solution would be left with sodium ions and nitrate ions. These two can also combine with each other, but the problem is NaNO3 that would be formed is going to be soluble, so they're going to remain part of the solution. They would dissolve back into the solution. They're going to dissociate back again. So two things would be formed. And here's my equation as well. Silver nitrate aqueous mixes with NaCl aqueous. It ends up forming AgCl solid, which settles at the bottom, and sodium nitrate would be formed, which would remain part of the solution. And what you're going to do is you're going to eventually filter this AgCl solid precipitate, and you can easily remove it. So this is what ionic precipitation is. Now let's go back to our question, and let's read the question again. Which statement describes how a pure sample of silver chloride can be made? So the first one is exactly the example that we did. Silver nitrate, mix it with sodium chloride, and you can get a precipitate of AgCl, which is going to be solid, and you're going to filter it out. So this option number A, looks perfectly correct. But also let's explore the other options. The second option is add aqueous silver nitrate to HCl, evaporate, and then crystalline. Now again, silver nitrate is going to contain silver ions, nitrate ions, HCl contains H plus 1 and Cl minus 1 ions. All four ions are going to mix together. A precipitate of Ag and Cl would be formed, and you just need to filter it. You don't need to evaporate it and crystallize because a solid is going to be produced. So it's an insoluble solid. You can't crystallize an insoluble solid. It's already in the form of a crystal. So the B option is incorrect. Option number C is also incorrect because reacting a carbonate with hydrochloric acid is going to produce a reaction. salt, water, and CO2 would be produced, but the salt is going to be AgCl. It's insoluble. It's insoluble, so you can't evaporate and crystallize. And this reaction would not occur because silver carbonate is a solid. So if you have AgCO3 solid, and if it reacts with HCl, the salt that would be produced is going to be AgCl. Now that AgCl is quickly going to form a layer on top of the silver carbonate, and it would stop. I mean, there would be water produced as well, there would be carbon dioxide produced as well in the reaction when carbonate reacts with acid. But since the salt is insoluble, that insoluble salt is going to form a layer on top of the silver carbonate, and it would prevent the reaction from happening further. So it's not a very good way of making AgCl. But the reason why C is incorrect is because you're not going to evaporate and crystallize, because AgCl is already a solid. You just need to filter it out. And the last one is you need to add silver to hydrochloric acid, filter, and then wash the residue. The problem with this reaction is metals react with acids, but the problem with silver is that it's very, very unreactive. It's very extremely unreactive. So the reaction is probably going to take a very, very long time, or it would require extreme conditions. You probably can't do it with dilute hydrochloric acid. So this is not a very good way of making AgCl, because hardly any reaction would happen because of the low reactivity of silver. So option D is also incorrect. So option A is again your correct option. The following question reads that dilute hydrochloric acid is added to separate aqueous solutions X and Y. So you're adding an acid, and it's a strong acid. The observations are shown. Now solution X, remember you're adding sulfuric acid. So let's write that down. You're adding sulfuric acid H2SO4 to the following solutions. So the first one, solution X produces a white precipitate, solution Y produces bubbles of a colorless gas. And then the question reads that which row shows the ions present in the solution. So let's look at option A first, barium ions. If you add barium ions to sulfuric acid, what's going to happen is sulfuric acid has it's a soluble acid, and its ions would dissociate. The H+1 ions and the sulfate ions, they're going to get dissociated. They will be dissociated and they would be found in solution in dissociated form. And if you add barium ions or any solution that contains barium ions into this mixture, what would happen is it's called ionic precipitation would happen, because barium ions, these positive ions, would combine with sulfate ions, and that would result in the formation of BaSO4, which is a solid which is insoluble. So it's going to produce this insoluble barium sulfate. So in the solution, these barium ions and these sulfate ions, they would get removed, and they would end up forming a solid which is going to be BaSO4 solid. So, and that would be a white precipitate, because group 2 compounds are always white. So this is correct. White precipitate would be formed. BaSO4 is going to be a white solid. And let's look at the next one. Your solution Y contains carbonate. Now it has a carbonate ion in it. Solution Y contains carbonate. You're adding sulfuric acid. So what happens when a carbonate reacts with acid? It produces a salt, a water molecule, and a carbon dioxide molecule, which is a gas. So you're going to see bubbles of a colorless gas. So the second option is also going to be correct. So option A looks perfectly right, because both observations would be obtained for option A. But I'll also comment on the other options. For example, C and D can't be correct because copper and iron are transition metals. So if they end up forming a precipitate, a solid, just like barium over here, that is going to be a colored compound. It's not going to be a white precipitate. So transition metals, they can't be present. It's going to result in a white precipitate. Over here, calcium is in group 2. So if you add calcium ions over here, they're going to combine with sulfate and form calcium sulfate solid. So white precipitate would be formed, but Cl-1 will not produce any gas or any reaction at all with sulfuric acid. So the second part of option B is going to be incorrect. So these two are going to produce colored precipitates. This would produce a white precipitate, but it's not going to result in the formation of a gas, or you won't see any bubbles. So option A is your correct option. The following question states that which element is less reactive than the other members of its group in the periodic table. So the first element that's given is acetine. So let's open the periodic table. So I'm showing group 7 now. You have fluorine, chlorine, bromine, iodine, and astatine. Remember, in group 7, the reactivity decreases down the group. Astatine is a big atom. It's a non-metal. All group 7 elements, when they want to react, they need to gain electrons. So if you're a very big atom, it's very hard to actually gain electron because the nucleus is surrounded by a lot of electrons. Fluorine is a very small atom. It's very easy for it to gain electrons. Its nucleus is not that surrounded, and it would be easy for it to gain electrons. So astatine is right at the bottom, so it's the least reactive of all the elements in group 7. So which element is less reactive than the other members of its group? That would be astatine. Astatine, that's a correct option because astatine would be the least reactive of all the elements. So astatine is correct. Fluorine is incorrect because fluorine is the most reactive of its group. Let's also look for cesium and rubidium. Now here are the group 1 metals that are shown. Now for metals, because they need to lose electrons, it's actually the bigger atoms that are the more reactive ones that easily lose electrons. So reactivity in metals, it tends to increase down the group. So lower down, the metals become more reactive. So you have rubidium and cesium. The least reactive one would be lithium. So that's not given in the option. It's cesium and rubidium that's given there somewhere in the middle. So that would not be correct. We were looking for the least reactive than the other members. So it's going to be astatine. That would be your correct answer for this question. The following question reads that the elements oxygen and sulfur are in the same group of the periodic table. Which statement about oxygen and sulfur is not correct? So what's the group? It's group 6 of the periodic table. They're both in group 6. So the first statement is they are non-metals. Group 6 elements are non-metals. They tend to gain electrons. They form negative ions. So that statement is correct. They have giant covalent structures, which is also it's actually not correct. So since we were looking for the not correct statement, they don't have giant covalent structures. So this statement is the one that is not correct. Remember the giant covalent structures, carbon, diamond and graphite, that's in group 4. And silicon dioxide, that is also in group 4. So group 6 elements, they are not forming giant covalent structures, not oxygen and sulfur. So B is the one that is incorrect. Let's look at C. They have 6 electrons in the outer shell, which is true because group 6 elements, they always have 6 valence electrons. D is they react together to form an acidic oxide. So sulfur and oxygen, they react to form sulfur dioxide and sulfur trioxide, which can be added to water to make acids like sulfuric acid. And if you add sulfur dioxide to water, that would be sulfurous acid, H2SO3. So they react together to form acidic oxides, which is also correct. So the only incorrect statement is going to be option B for this question. The following question reads that why are weather balloons sometimes filled with helium rather than hydrogen? So you have weather balloons and you fill them with helium. Now the reason, these two gases are very light. Helium has an atomic mass of 4. Hydrogen has an MR of 2. Compared to air is on average it's 29 because air is 29. The reason air is on average is 29 is because it contains molecules of N2 which are 78% and molecules of O2 which are 21, which make up 21% of air. So the average of N2 and O2, that comes out to be around 29. So these are very light gases compared to air. So they're going to go up. So why do we fill weather balloons with helium? Let's look at the first option. Helium is found in the air, which is true, but it's not the reason why we are filling it with helium. Helium is less dense than hydrogen, which is wrong because helium has a higher mass. Its atomic mass is higher. Helium is more dense than hydrogen, which is also correct, but we're not comparing the two together. Basically, we want the weather balloon to be less dense or lighter than air. So that doesn't really make sense. The last option is the correct option because we want, the reason helium is used is helium is very unreactive. It's a noble gas. It has a complete octet of electrons. It doesn't need electrons, doesn't lose electrons. It's very unreactive. So it's going to last longer. Problem with hydrogen is hydrogen explodes. It readily reacts with oxygen in the air. So there are chances of explosion that hydrogen is going to burn and end up producing water molecules. So hydrogen is therefore not preferred in weather balloons or any balloons that you're filling. Helium is the number one choice because it's unreactive. It's going to last longer, and there are lesser chances of explosions. The following question reads that which process is involved in the extraction of zinc from zinc blende? So we need to just quickly go over what is the extraction of zinc, how is it carried out. So there are two steps in the process. The first step is ZNS is roasted in air or burnt in air. So it reacts with oxygen and ends up producing zinc oxide and sulfur dioxide. And in the next step, ZNO is then that is produced in the previous step is then reduced with carbon. So carbon being more reactive, it's going to take away all the oxygens from zinc, and zinc metal would be produced and carbon dioxide would be produced. So these are the two steps of the extraction of zinc. So which one is correct? Cryolite is not used in extraction of zinc. It's used in bauxite extraction of aluminium. So the first statement is incorrect. No use of cryolite over here. The next one is molten zinc blende is electrolyzed. No electrolysis is done. Instead, you react it with carbon, which is going to reduce it. Third option is zinc blende is heated with carbon. We are heating it with carbon, but not zinc blende. We are heating zinc oxide. Zinc blende was ZNS. We're roasting it. So the last statement is actually correct. Zinc blende is roasted in air. So the first step is you burn zinc blende and then you produce zinc oxide. So option D is going to be your correct option for this question. The following question reads that element E has the following properties. It forms an alloy. So alloys are formed by metals, but there could be non-metals involved as well. But it has a basic oxide. Remember, metal oxides are the ones that are basic. So metal oxides are basic, which means that it must be element E must be a metal. Last one is below hydrogen in the reactivity series, which means that it is very, very unreactive, because if you remember the reactivity series, so here's the reactivity series, you will notice that hydrogen over here is very less reactive. So these elements are very less reactive. So it must be one of these elements. So coming back to the question, what is E? So we know it's a metal, it's forming alloys, and it's very unreactive somewhere over here. So it's going to be option, it's not a non-metal, so A and C are automatically removed. You have two metals, one is copper and the other one is zinc. But zinc is pretty high up in the reactivity series. It's over here, hydrogen over here. We need a metal that is less reactive. So it's going to be copper. Copper would be the correct option for this particular question. The following question reads that a list of metals is shown. So these are the metals that are provided, and the question now is which metal will displace all of the other metals from the aqueous solutions of their salts. Now, which metal will displace the most reactive one? The most reactive metal is going to displace all the other metals from their solutions. For example, if you take Mg and you mix it in copper sulfate solution, Mg is being more reactive, it's going to kick out copper, and it would form MgSO4 and copper would be displaced. So here I have written down the reactivity series that should be memorized by heart. Let's figure out which of these metals in the list is the most reactive one. I can think of Mg being right at the top. So there's Mg over here, that's very reactive. I think there is no other element that is more reactive than Mg. So which metal will displace? It's the most reactive one that would displace any metal in the list that's given. So option C would be the correct option. It's going to be magnesium. The following question reads that stainless steel is an alloy of iron and other metals. It is strong and does not rust, but it costs much more than a normal steel. What is not made from stainless steel? So stainless steel, as you already know, you're probably familiar with this. Most of your cutlery and very shiny objects are made from stainless steel. It doesn't rust. So what is not made from stainless steel? Cutlery, your spoons, etc. They are made from stainless steel. So what do you not make from stainless steel? Pipes in a chemical factory, you don't want those pipes to rust or react. So you don't want, it does not rust, it doesn't react. So you don't want pipes in a chemical factory to rust or react. So you're going to make them with stainless steel. Saucepans, your food containers, because you're heating them and you're cooking food in them, you don't want it to react or burn or rust. So what is not made? Railway lines are not made using stainless steel. They're made from steel. not stainless steel. And the reason why railway lines are not made from stainless steel is it's the number one is cost. Because railway lines you need a lot of metal and you can't have very expensive stainless steel. Although it would be preferred, if in an ideal world you would be making railway lines out of stainless steel, you don't want railway lines to rust as well. But since stainless steel has a higher cost, you can't really afford a stainless steel railway line because it's a lot and lots of steel that is required. So that's just normal steel. So option C is correct. The diagram shows some uses of water in the home. So this over here is water that's used for cooking, for cleaning car, for you're watering the plants as well. For which use it is important to have the water to be treated? Well, for cooking, you need the water to be very, very clean because harmful bacteria, etc., can enter your body and they can cause sickness. So one only would be the correct option. You want very, very clean water for cooking or for human consumption. For cleaning cars, the water could be impure. As long as it's somewhat clean. You don't want it to be perfectly treated. Similarly, for plants, you don't want it to be treated. You can use just raw water, and you can use it for watering plants. So only for cooking, for human consumption, you need very, very pure water. So one only is the correct option for this particular MCQ. The following question reads that the carbon cycle includes the process of combustion, photosynthesis, and respiration, and which row shows how each process changes the amount of carbon dioxide in the atmosphere. So I've listed all the three processes. Respiration is the process where your body produces energy. It takes in glucose, reacts it with oxygen, and ends up producing carbon dioxide and H2, and this is the process by which your body produces energy. Combustion is the process where different fuels, hydrocarbons, etc., they are burnt in oxygen and they produce carbon dioxide and water. You can notice that in respiration and combustion both, carbon dioxide is the gas that is being produced. So they're going to increase the amount of carbon dioxide. So the question was which row shows how the process changes the amount of carbon dioxide. So we're going to look for respiration and combustion. They're going to increase. And this last one, photosynthesis, does the opposite. It takes in carbon dioxide, takes in water, and ends up forming glucose and oxygen. So it consumes all the oxygen, carbon dioxide. The carbon dioxide gets converted into oxygen back again. So this is the process which decreases the amount of carbon dioxide. So option C is going to be your correct option for this question. The following question reads that which statement about the conditions used in the Haber process is not correct? So this here is your Haber process where nitrogen and hydrogen react and they produce ammonia. The temperature is 450, pressure is 200 atmospheres, and you have a catalyst in the form of iron or Fe2O3. So which statement about the conditions used in the Haber process is not correct? The first one is a higher temperature is used because the forward reaction is exothermic. Now remember this, forward reactions, if they are endothermic, now remember this is an equilibrium reaction. If it were endothermic, although it is exothermic, but if it were endothermic, then higher temperature would be favorable because higher temperatures, they support endothermic reactions. But since it's not endothermic, it's an exothermic reaction. Exothermic reactions prefer lower temperatures. So this reaction in the forward direction is an exothermic reaction. So exothermic reactions, they prefer lower temperatures. So the reasoning is not correct in this statement. So you're not using higher temperatures, you should be using lower temperatures because the forward reaction is exothermic. Let's move to the next statement, which is that a high pressure is used because there are fewer moles of gas in the products than in the reactants. So whenever you increase pressure, less gas moles side is favored. The side that has fewer gas moles is going to be favored because when you're increasing pressure, you're compressing. If you're compressing, that means the space is running out and fewer gas molecules would be produced. So in the product, there are 2 molecules. In the reactants, there are 4 molecules of gas. So this statement is correct because if you increase pressure, the forward reaction will be favored. There are lesser gas moles in the product side. So this is correct. A higher pressure is used because there are fewer moles of gas in the products than in the reactants. So more products would be produced. So this statement is going to be your correct statement. We're going to check C and D as well. An iron catalyst is used to increase the rate of the forward reaction. Well, it is used to increase the rate of the forward reaction, but it also increases the rate of the backward reaction. So this statement also looks to be correct. So option C is also correct. The last one is that the unreacted hydrogen and nitrogen are recycled to increase the amount of ammonia. Remember, not a lot of ammonia is produced. I think the yield is probably 15%. So only about 15% ammonia is produced. The rest of the reactants, the unused reactants, are reused or recycled. So this statement is also correct. So what we did not look in the first statement correctly is we're looking for the not correct statement. So option A is your not correct statement. So your correct answer is going to be A. The following question reads that which chemical reaction decreases the pollution in air? So the first reaction, SO2, is a pollutant. It causes acid rain. So that is a pollutant. So that's not decreasing pollution. The second reaction is producing nitrogen monoxide, which is also going to cause acid rain. So that's also not decreasing pollution. The third reaction produces carbon monoxide. Now, carbon monoxide is also a pollutant. It causes choking, and it also causes breathing problems because it combines with hemoglobin and destroys the red blood cells, or so they're not able to carry oxygen. So that's also a pollutant. It's a harmful pollutant. If you look at the last one, your nitrogen monoxide, which is a pollutant, and carbon monoxide, as we discussed earlier, they're pollutants. They're getting converted into compounds that are not considered pollutants. So carbon dioxide is a perfectly safe gas. Nitrogen is also 78% of the atmosphere is nitrogen, so it's also perfectly safe. So these two gases are perfectly safe. They are not pollutants. Overall, this reaction is decreasing the amount of pollutants. So a decrease in pollution is happening in option D. The following question reads that which statement about sulfuric acid, which is H2SO4, is correct? So the first one, it is made by the Haber process. No, it's not made by the Haber process. It's made by the contact process. In the contact process, H2SO4 is made. So option A is incorrect. Second one is it is made in the atmosphere by the action of lightning. Now, the action of lightning burns air which contains these two oxides, nitrogen and oxygen, and ends up producing nitrogen monoxide and NO2, not sulfuric acid. So that is also incorrect. The next one is it reacts with ammonia to produce fertilizers. This is correct because a lot of fertilizers, they are produced when ammonia and sulfuric acid, they react and they end up producing ammonium sulfate, which is a salt. That salt is used to produce, that's used as a fertilizer. So this statement, option C, is going to be, it's a correct statement. But we're going to look at the third option as well. It reacts with copper to produce hydrogen gas. Now metals, they react with acids like sulfuric acid to produce hydrogen gas. But the problem with copper metal is it's very, very unreactive. So it's extremely unreactive, and it's not going to lead to any reaction. Or a very slow reaction would happen. So this reaction would probably not happen. So option C looks perfectly alright. Ammonia and sulfuric acid produce ammonium sulfate, which is used as fertilizer. The following question reads that statements about methods of manufacture and uses of calcium oxide are shown. Now, calcium oxide is lime. It's frequently used in a lot of different ways, specifically for curing acidic soil and removing acidic gases from factory flue gases. So the first one is it is manufactured by reacting acids with calcium carbonate, which is not correct because calcium carbonate with acids is going to produce salts. This is not a salt, this is a base. It's a metal oxide, it's a base. Next one is it is manufactured by heating calcium carbonate, which is correct because you take limestone and you decompose it. You heat it decomposes, ends up producing a metal oxide and carbon dioxide that results in the formation of lime. So limestone is used, it is heated. So this statement, option 2, is correct. Next one is it is used to desulfurize flue gases. which I've already told you that's a correct statement, because calcium oxide and your acidic gases like sulfur dioxide and nitrogen dioxide, these two gases are acidic. They combine and they end up forming salts like calcium sulfide and calcium nitrate. So these salts are produced during this reaction. So the flue gases get neutralized, end up forming salts. So it is used to desulfurize flue gases. That is a correct statement. And it is used to treat alkaline soil. This itself is a base. Calcium oxide is a basic compound. It reacts with acidic soils. It's used to treat acidic soils. So this alkaline part is incorrect. It should be acidic soil. So the fourth statement is also incorrect. So the correct option that you're going to have is 2 and 3 are the only correct statement for this question. The following question is talking about the industrial fractional distillation of petroleum, and it's shown this is your fractional distillation. You have petroleum is a mixture of different compounds, and these compounds are separated by fractional distillation. So petroleum vapor is passed through this chamber, and as it cools, the higher melting boiling point, bigger molecules, they condense first. So you obtain these bigger molecules first, and smaller molecules, because they have lower melting and boiling points, they condense later. So you get all these fractions. Now the question is, which process happens at Y? Y is the part where you're evaporating this petroleum. You're evaporating it. So the correct option is going to be evaporation. So the evaporated petroleum is passed through where it condenses slowly as the melting and boiling points temperature drops, and you get different fractions at different points. Higher temperatures at the bottom, so higher melting boiling point substances, they condense first, and lower melting and boiling point substances, they condense later on. The following MCQ states that which statement about homologous series is not correct. So what's a homologous series? A homologous series is a family of organic compounds with certain properties that they share their chemical and physical properties, and they have the same functional groups. And so similarity, different organic compounds are grouped according to certain similarities. So the first one, alkenes have the same general formula CnH2n plus 2. This one is incorrect. The general formula of alkenes is CnH2n. That is the general formula of alkenes. Next one is that each member of the homologous series of alkanes differs from the next by CH2. This is correct, and he's talking about alkanes. So if I draw the first one, which is methane, and that's one carbon atom, and if I draw another one, which is ethane, it's two carbon atoms with a saturated molecule with single bonds, all hydrogen atoms. So you can count the difference. There's the difference of one carbon atom and the difference of two hydrogens. This has 4 hydrogens, this has 6 hydrogens. So the difference is CH2. So between two successive alkanes, the difference in the number of atoms is going to be CH2. So that statement is correct. Let's look at C. The member of homologous series all have similar chemical properties. This statement is also correct. That is why you're putting them all in the same chemical, same family of compounds or same homologous series. And option D is the members of homologous series all have the same functional group. So they have the same group of atoms, which is why they always have the same chemical reactions. So this statement is also correct. So since the question was asking for the not correct statement, it's going to be 1, because alkenes have the general formula CnH2n, not CnH2n plus 2. So A would be your incorrect statement. That would be your answer to this question. The following question reads, the diagram shows part of a molecule of a polymer. Which diagram shows the monomer from which this polymer could be manufactured? Now, it's a polymer, and it's a product of addition polymerization. So the only option that you're going to be left with is this one, and I'm going to show you how you can get this polymer from this molecule of ethene. Over here, as you can see, I've drawn all these ethene molecules. What's going to happen is in addition polymerization, under high pressure, these molecules are going to group together, and they would start connecting with each other. The double bonds are going to get converted into single bonds. So the double bonds are going to get converted into single bonds, and the molecule, the carbon atoms in the molecule, they would start joining with each other, and they would start linking up, and they would start forming a very long chain molecule, which would be called a polymer. So if you go back to the question, You would notice that this is the same molecule that I drew, and these molecules, they're going to group together, they're going to connect with each other, and they would form this polymer. Following question reads that ethanol is manufactured by fermentation or by the catalytic addition of steam to ethene. So, what is the advantage of ethanol manufactured by fermentation instead by the catalytic addition of steam to ethene? So, I've listed the two methods for the formation of ethanol. The first one is from glucose fermentation. You use the yeast. It's a slow process, but it happens at room temperature. No special conditions are required except for absence of air. But it also has a very less yield, because as soon as ethanol is produced, the yeast gets killed because of the ethanol, and the reaction stops. So a very small quantity of ethanol is produced in this way. The other one is you take ethene from crude oil. Crude oil is where you're going to get ethene. It reacted with water, but the conditions are extreme. You need phosphoric acid catalyst, 300 degrees centigrade temperature, and you need 60 atmosphere pressure. So ethanol would be produced. So the question is, what is the advantage of ethanol? Ethanol manufactured by fermentation. The first one is ethanol manufactured by fermentation is purified by distillation, but that is probably not an advantage. We are looking for what is an advantage. The second one, ethanol manufactured by fermentation produces pure ethanol. It definitely doesn't produce pure ethanol. I just told you that ethanol, as soon as it is produced, it kills off the yeast, so the reaction stops. So the percentage of ethanol in this mixture is not going to be very high. The third part is ethanol manufactured by fermentation uses large areas of land. You can store them in cellars, etc. So I don't think you need very large areas. And even if you do need large areas, that is not going to be an advantage. It's going to be a disadvantage. The last one is that ethanol manufactured by fermentation uses renewable sources. This statement is definitely correct, because glucose, if you're making ethanol from glucose, glucose can be obtained from different fruits, different plants, and you can grow glucose. So it's a renewable source. You can always grow plants. So this is going to be renewable resources. That's correct. The other one is non-renewable, because ethene is you get ethene from crude oil, which you only have a limited supply of crude oil. The following question reads that the formula of an ester is given, and which acid and alcohol react together to make this ester. So this is the ester that's provided. Let me draw a more displayed formula of this molecule. So this is a more displayed formula where I've this COO, I've drawn it in a displayed form showing all the bonds. So what happens? You need to find out which two substances react together to produce this particular ester. The way you can find this out is just break this ester. So you can break this ester link, and you're going to get this molecule CH3, CH2, and another CH2. And remember, the C double bond O part, this is one part that you're going to get. The other side is going to be O followed by CH2, another CH2, and another CH3. And this double bond O side is going to be a carboxylic acid side. This side is a carboxylic acid side. This single O side is your alcohol side. So you have finally found your reactants. One is 1, 2, 3 carbon atoms. So this one is propanol. It's an alcohol because it only has one OH. This other side is 1, 2, 3, and 4 carbons, which means that it is butanoic acid. So it's butanoic acid and propanol. They're going to react together to produce this ester. They're going to lose, the carboxylic acid loses its OH, the alcohol loses its hydrogen, and they join together to form this ester over here. So the correct answer is going to be option B, butanoic acid and propanol. That's your correct option for this question. The following question reads that polyesters and polyamides are types of synthetic polymers, and which statement are correct? So first, let's quickly go over polyesters and polyamides. So here I've drawn the two images of polyamides and polyesters. So what are polyamides? Polyamides take this diamine. It's a molecule that has NH2 on both sides, and there's a diacid or dicarboxylic acid which has a carboxylic acid group on both sides. So the H is lost from the amine, and the OH is lost from the carboxylic acid. These two end up linking with each other. That results in the formation of an amide link. And this process is going to repeat with the other monomers. It's going to keep on repeating. So a polyamide molecule will be produced where there would be amide links, amide links, amide links everywhere. The other one is polyester. Polyester, you again have two monomers. One is a molecule of dicarboxylic acid, exactly like in polyamides, a carboxylic acid group on both sides of the molecule. That molecule is represented by a box, so it could be anything. But it would have a carboxylic acid group on both sides. And there's going to be another molecule, a monomer, that would have OH groups on both sides. So there would be OH groups, carboxylic acid groups, and they're going to repeat. The EH is lost from the alcohol, the OH is lost from the carboxylic acid, and this oxygen would end up joining with this carbon atom. It would result in the formation of this ester link. And there would be lots of ester link on both sides, and that would result in the formation of polyester. So now we have quickly done a revision of what condensation polymerization is. Let's go back to our question now. So let's read the first reaction. They are made by addition polymerization, which is incorrect. They're not made from addition polymerization. They're made from condensation polymerization because water is produced in each reaction. The next one is they're made from condensation polymerization. This statement is perfectly right. The third statement is that the monomers from which they are made are unsaturated hydrocarbons. This is also incorrect. Unsaturated means you're making it from alkenes. So those monomers were not alkenes. They're not made from alkenes. So the second statement is correct. The third is incorrect. And the fourth one is the monomers from which they are made contain reactive functional groups at their ends, which is correct. If you have a look again at the monomers, these monomers, amine on both sides, carboxylic acid on both sides. So these are reactive functional groups. So the fourth statement is also correct. So you have the second statement which is correct, they're condensation polymers, and the fourth statement which is correct, that they contain reactive functional groups. So 2 and 4 are going to be correct. Option number 2 and option number 4.